Hi there. Let's do, this is an example from section 3.7. This is number 33. It's one of the homework assignments, and it's a pretty hard problem, pretty interesting, not too hard. And what it says is you want to find the maximum volume that a box being sent through the post office can have if it's got to be, it's going to be L inches long and X inches, so it'll be a square on a side. And the maximum of L plus 4x, so that's called the length and the girth, has to be less than or equal to 108 inches. So we want to see what the maximum volume. So we want to maximize volume. So we're going to write an equation for volume, and then we're going to be constrained by this requirement here. And when we do that, we can figure out what the actual biggest box that we can, the dimensions of the biggest box we can make that'll maximize that volume, and we'll prove it with the second derivative test. So the volume of this box is going to be, volume is always going to be length times width times height. In this case, it's going to be, let's say, the length times x, because these are both going to be the same. It's going to be, we're going to require it to be a square box. So the end is going to be square. Okay? So we've got that. And then we also know this is the case. So we can solve this pretty easily. We're going to make this an equals. Solve this for L. So you're always going to do this. You're going to have an equation probably with more than one variable in it of whatever it is you're trying to maximize or minimize. And then you're going to have another equation that relates those variables somehow. And you're going to take that other equation and solve for one of the variables and substitute into that equation you're trying to maximize or minimize, and therefore you'll be able to differentiate it and set it equal to 0 and find where the maximum occurs. So let's solve this equation for L. So L is going to be 108 minus 4x. And we're going to take that 108 and 4x, minus 4x, we're going to put it in here for L. So we get another equation for volume equals 108 minus 4x times x squared. And before you differentiate it, simplify it a little bit. So we're going to distribute here. So we get volume is equal to 108x squared minus 4x cubed. And now we're ready, once we've got this volume, whatever it is we're trying to maximize or minimize, we need an equation for that with only one variable in it. And then we can differentiate that equation with respect to that variable, set it equal to 0, and therefore we'll find the maximum or the minimum. So this is going to be dv dx, and it's going to be, let's see, 2 times 108 will be 216, x to the first power, minus 12x squared. So that's the derivative. We're going to set that equal to 0 and solve for x. So right away we can see we can factor out an x. We might be able to factor out a 12x. Let me see here if we can do that. So 216, does 12 go into that evenly? It does. So we can factor out a 12x here. And what's left is going to be 18x minus an x equals 0. So obviously, we could make x equal to 0. That'll give us an extrema. In this case, it would be a minimum. If we make the the end of the box nothing, we'll have minimum volume. On the other hand, here we factored out a 12x, so this shouldn't be an x, so it should just be 18. So 18 minus x will tell us the other extrema that's going to occur, and we're hoping that's going to be a maximum. We'll check that with the second derivative here in a minute. All right, does that make sense? So we factor out a 12x, we've got 18 minus x left. So when I make that equal to 0, obviously 18 minus x equals 0, x is going to equal 18. So if we make the end of the box 18 inches, that'll maximize our volume, we hope, and we'll check on that in a minute. Then we're going to put it right in here and see what the length should be. So we make each edge of the side 18 inches. So L is going to equal 108 minus 4 times 18. So that'll be 36.
Mr. Hiles! Why did you not come in? Hi.
Hi there, come on in.
How are you doing?
You can help me. You can help me do. You can help me do a recording.
Oh, out of here! Sorry.
Oh, Justine and Sam are here. Sorry about that interruption. So anyway, L equals 36. The sides are going to be 18. So, and we can figure out the volume there if you put that back into the volume equation. But let me draw a picture that looks a little bit more realistic. So the width should be exactly half the length. So if this is, 36 inches here, then the width is going to be 18, about half of that. Now that's kind of interesting, the way that works out, that this will be 18 inches. And that'll give us a box of maximum volume. Let's do the second derivative and see if it really does work out that way. So here's our first derivative. V prime equals 216x minus 12x squared. If I take the second derivative, V double prime, I get 216 minus 24x. And what I have to do is I have to put 18 in here. So this is, a little bit of something to think about. I want to put my minimum value or maximum value in there and see what that equals. So now I'm just going to do that on my calculator. 216 minus 24 times 18. And I get negative 216. So V double prime, when x equals 18, is going to be negative 216. And of course, a negative value means, so this is negative 216, that we have a maximum. So that's exactly what we want. Okay, so try that. You're going to have to try a bunch of these, and we'll do some harder ones a little bit later. Okay, we'll talk more Monday about these.